And now how scientists are working on improving weather forecasts in Futuris. In August 2002, after weeks of hot, dry conditions, the weather across Central Europe finally broke. Torrential rain fell for a week, sending water surging through the river systems of Germany, Russia, Austria and the Czech Republic. Thousands were evacuated. At least 90 died. In the historic city of Dresden in eastern Germany, the River Elbe rose to a level of more than 9 meters. It was the highest level since records began in the 16th century. 30,000 residents were forced to flee their homes. Officials worked frantically to protect the city's treasures. A few kilometers upstream from Dresden in Bad Schandau, floodwaters were about to engulf the town. Gunter Vihudi, a shopkeeper, remembers the 16th of August very well.
We saw that the streets were flooded, and this was when we realized that we had to think ahead and that we were about to be exposed to great danger. We tried to take out stuff from the basements and put it somewhere safe, and then we were informed that the city was to be evacuated, that we had to get out, and we just had to accept it.
Dass man dann raus musste, das war dann die Wahrheit und dass man dann sich damit abfinden konnte.
The residents of Bad Schandau are used to floods. Gunter has a flood diary on the wall outside his shop. A team of researchers in Britain is now working to ensure that people have more warning. At the European Centre for Medium-Range Weather Forecasting in Reading, west of London, scientists are dedicated to improving the accuracy of forecasts. One of the techniques being used is ensemble forecasting, where 50 different simulations are run, each with slightly different information.
The basic idea is this, that instead of running a single weather forecast every day, we would run 50 different weather forecasts. We would run our model 50 times. If all the 50 ensemble members agree with one another perfectly, then the person that's using the forecast will know this is a forecast that we can have confidence in, we can rely on it. If the forecasts are different, we can't be certain that this severe event will happen, but if they happen in 20 out of the 50 forecasts, that gives the user a warning, actually, of the risk of a severe weather event.
One tiny difference in data can change an entire forecast, sometimes dramatically. This was the case with Lothar, a violent cyclone which devastated part of Europe in December 1999. One simulation didn't predict the storm at all.
What this shows are two weather maps, and by eye they look identical. But they are very slightly different from one another because they have these uncertainties in the observation. Now, as we start to get into Boxing Day, then something very dramatic happens in the lower of the two weather maps. There's this very intense vortex. So if you were a poor forecaster having to make a TV forecast and all you had available was that top weather forecast, you would get it completely wrong because you would say it's not a very bad day, it's a bit of sort of westerly wind, nothing very dramatic. Whereas if you had had the lower map, you would have said that this was a really severe weather event.
The factors which influence weather are not confined to countries or even continents, so the plan is to link world weather centres to arrive at a truly global forecast. This is the aim of Project SIMDAT, an initiative that will allow users to access world weather data from several sites. Baudouin Raoult runs the Weather Centre's Data and Services section.
What we try to achieve is to create a one-stop shop to allow users to discover meteorology data, which is scattered over several sites. They will find the relevant data sets, and then through the same portal we'll be able to retrieve data which is remotely stored over the network.
Hundreds of millions of pieces of information are required for accurate forecasting, and a recent initiative by the European Commission is proving itself invaluable, called Géant 2. It's a high-speed information network that uses optical fiber to connect scientists globally.
What is really required is speed, because the volumes we are dealing with are very large. We are talking about hundreds of gigabytes. So what Géant 2 gives us is really the ability to provide a fast delivery mechanism of this large amount of data that the meteorological world requires.
Back in Dresden, the city is preparing for more floods. Part of the outlying city is protected by dikes, but the old city is a different matter. The authorities are planning a series of measures to protect the ancient buildings. Frank Frenzel is part of the Dresden Flood Protection Task Force.
You see here a model of the future protection line, which will shield the inner city of Dresden and two parts, Friedrichstadt and Wilsdruffer Vorstadt. We will use the old wall of Dresden from the old times, and we will build a sandstone construction on top of it in future years. This will provide protection up to a water level of the Elbe of 9 meters. Should the Elbe rise higher than 9 meters, we will be able to provide protection by putting up these mobile barriers. However, for this we need time, because we need specialized personnel and time to do this. This is why an early warning system is essential for the city of Dresden.
Bedarf geschulten Personals und auch Zeit. Insofern ist eine rechtzeitige Vorwarnung für die Stadt Dresden essentiell.
As Europe experiences more frequent catastrophic weather events, forecasting them accurately is becoming increasingly critical. The Environment and Geology Agency is responsible for flood warnings for Saxony, a region of 15,000 square kilometers, including 7 river catchment areas.
Weather forecasts are very important for us, because in our small area floods develop very quickly, and it is very important to know early on how much water will be coming down and where exactly this water is going to come down, so that people living in this area can be warned.
One of his responsibilities is Bad Schandau. Due to its position in a narrow river valley, early warning is the only defense for its citizens, something they didn't have 5 years ago.
It was very unclear what would happen. There were no exact forecasts. Neither were we able to say what level the water would reach, which is important to us for saving our valued possessions. At the end, you really could say that we were left in the air.
According to many experts, bad weather events are set to increase in both number and severity.
Weather systems will actually become more and more intense and severe, and so an ability to forecast these severe weather events ahead of time becomes a more and more important aspect for society to be able to adapt to climate change.
Through the SIMDAP project and the GEONT 2 network, the European Weather Centre offers researchers easier access to a pool of data, allowing them to provide even more accurate alerts of severe weather events.